Today I'm going to help you with your notes on graphing trig functions. We're going to start again with y equals sine x. Notice here we're talking about angles between negative 2 pi and 2 pi. Yesterday we talked about these angles in degrees. So this is the same thing as talking about theta between negative 360 and positive 360. Remember, for the sine of 0 is 0. The sine of 90 degrees is the same thing as pi over 2, which is 1. The sine of 180 degrees, which is pi, is 0. And the sine of 270 degrees, which is 3 pi over 2, is negative 1. And the sine of 2 pi is 0. This pattern repeats for the negative angles as well. So we get the nice smooth sine curve. The domain is all reals. We can find the sine of any angle measure. The range, however, is between negative 1 and positive 1. The graph never gets higher than 1 or less than negative 1. There are no asymptotes in this graph. Remember, an asymptote is a line that the graph approaches but never touches. The x-intercept are the multiples of pi: 0, pi, 2 pi, 3 pi, and so on. Multiples of pi. Remember, pi is just 180 degrees. The y-intercept is 0 because the sine of 0 is 0. The period is the length of time that it takes for the graph to complete one full cycle. In radians, this would be 2 pi, which is the same thing as 360 degrees. Now we'll move on to cosine. The cosine curve, we're going to graph angles between 0 and 2 pi, which again is the same thing as angles between negative 360 and 360 degrees. Cosine. The cosine of 0 degrees is 1. Remember, we found these values from the unit circle yesterday. The cosine of 90 degrees is 0. 90 degrees is pi over 2. The cosine of pi radians is negative 1. 3 pi over 2, which is 270 degrees, has a cosine of 0. And 2 pi radians, I don't want that dot there. 2 pi radians has a cosine of 1. Remember, that's just 360 degrees. I keep putting that dot there. 2 pi, there we go, cosine of 1. And again, the pattern keeps repeating. We draw on our smooth curve. And there's our cosine curve. With the domain of all reals, a range between negative 1 and 1. No asymptotes for this graph either. These x-intercepts are multiples of pi over 2, or 90 degrees. The x-intercept is 1 because the cosine of 0 is 1. And this period is the same as the sine. It takes 360 degrees, or 2 pi radians, to complete a full cycle. Now you're probably wondering what the tangent graph looks like. Tangent's kind of an oddball. Let's go back to our unit circle. Remember that tangent is y over x. So when I take my points on the unit circle, (0, negative 1, and I divide y by x, I will get my values of the tangent. Here at 0 radians, the tangent would be 0 divided by 1, which is 0. at pi over 2 radians, which is 90 degrees, I would have 1 divided by 0, which is undefined. This is where we're going to find an asymptote. At pi radians, or 180 degrees, the tangent is also 0. And at 3 pi over 2, which is 270 degrees, think about the point on the unit circle. Again, we would have negative 1 divided by 0, which is undefined. Anywhere the tangent is undefined, we're going to have an asymptote. So this is also going to occur at negative pi over 2 and at negative 3 pi over 2. Again, we notice a repeating pattern. Now, the tangent between 0 and pi over 2 increases, and it approaches the asymptote. Between 0 and negative pi over 2, it decreases and approaches that asymptote. So we get this smooth-looking curve in between our asymptotes. And that's the pattern that repeats. Tangent's kind of funky. Okay. Those branches make up the tangent. The domain for the tangent is all reals. Except where your asymptotes are. And your asymptotes are odd multiples of pi over 2. Remember, we had an asymptote at pi over 2, 3 pi over 2. There would be another asymptote at 5 pi over 2. So our domain cannot include those angle measures where the asymptotes are. Our range for the tangent is all reals. The x-intercepts are multiples of pi, or 180 degrees. Our x-intercepts, our y-intercepts, the y-intercept is 0. The tangent of 0 is 0. The period of the tangent function is different than the sine and cosine. It makes a full repetition in pi radians, or 180 degrees. This is the piece of the curve that continues to repeat. And between negative pi over 2 and pi over 2 is pi radians. So the period of the tangent curve is pi radians.